In the last problem, we got this answer. X equals to 5 plus or minus the square root of 73 over 6. Now I want to address the issue of calculating this or approximating it. This is an exact algebraic answer, incidentally. Exact algebraic answer. And I want to emphasize that it's exact in this form, and because it's in symbolic form. The square root of 73 in decimal form just goes on forever, and there's no pattern to it. It's an irrational number. And so you cannot write the square root of 73 down as an exact number in decimal form. It's impossible because it goes on forever. But we could approximate it. And if people who actually need to do this, apply this to their work, engineers and other types of people, would be interested in getting the approximate answer. And so that's the issue we want to tackle here. So I think, fine, we can get this. We've done the algebra. Now let's see if we can make use of it and get some kind of practical answer to it. So in order to do that, you really need to write these out separately because there are two different calculations here. So it's 5 plus the square root of 73 over 6, and 5 minus the square root of 73 over 6. And think about it this way: when you punch them on your calculator, think of the numerators as being in parentheses, because your calculator only understands the order of operations. And if you punch in 5 plus the square root of 73 over 6 divided by 6, in other words, if you did 5 plus the square root of 73 divided by 6 on your calculator, you're going to get the wrong answer, because what your calculator thinks you want is this result, not that result. And so in order to get this result, we have to wrap that in parentheses, because that will tell the calculator to combine these numbers together before you divide by 6. So that's, the common error people make is precisely this: that you forget their parentheses keys and they end up doing this calculation instead by mistake. All right, so now calculators differ, and there are two main types. And here's the issue: how do you do the square root of 73? Well, if you have a sort of an older calculator or a more primitive model, most of those models you have to type in 73 and then hit the square root button. However, some of the more recent models of calculators, the more sophisticated ones, and I think every graphing calculator, you would punch in square root followed by 73 to do that calculation. So you need to learn which is which. And the square root of 73, I've got a graphing calculator, so I punch it this way. I do square root 73, and I get about 8.544. So you should try this on your calculator. Make sure you know which one you got, which type you have, so you know how to punch this in. Some calculators, if you lead off with the square root button, you'll see something like this. It'll throw a little parentheses in here, and then you'll type in your number, and then you have to close the parentheses. So for those of you with those type of calculators, you may have an extra set of parentheses around your number here. In this case, 73. You may have yet another set of parentheses. So that shows up on a lot of current calculators. All right, well, I'm going to calculate this, and you should try this to make sure you get my answers. And so here's how I'm going to punch it on mine. I'm going to type in left parentheses 5. I'm not typing in commas, that's just to separate these. Left parentheses 5 plus the square root button 73, right parentheses, divide by 6, and then hit equal. So on my calculator, that's the sequence, and that will work on many of yours. Some of you, again, may need an extra parentheses here. If your calculator gives you a parentheses with the square root button, then you'll need an extra parentheses. And for those of you with the other types of calculators, you'll need to switch these two. You'll need to put 73 and then square root button, and then hit the right parentheses. So however you do that, let's see, what do you get? All right, so you should get divided by 6. X is approximately 2.257. That's one of my answers. And the other answer is negative 0.5, whoops, mistake here, 591. There we go. Now this one had to be rounded up because, let me show you that. Let's talk about rounding, because I expect you to round numbers correctly. Rounding is a way of minimizing the errors you make when you cut numbers off. And I typically go 3 decimal places on these. There's nothing sacred about that, but 3 decimal places usually gives me 3 or 4 significant places, and that's usually pretty good. On this one, my calculator showed 2.25733395755. Okay, and rounding off to 3 places means looking at the 4th place, and since it was 3 or less, then I just cut it off, 2.257. But this number came out negative 0.5906672908886, and so when you round off the 3 places, you look at the 4th place, and it's a 5 or higher, turned out to be a 6. So I rounded up this last place to a 1. So that's rounding. If you want full credit, then you'll need to calculate these and round them off properly. Either round off or round up, as the case may be. So there you go with that. Now this answer, and notice I wrote it with a little wavy equal sign. That wavy equal sign means approximately equal to. And so I like to use it because that tells the reader that this is an approximation. It's not exact. It's close. And this I call the approximate decimal answer. All right. So up here we have the exact algebra answer, which is in symbolic form. And here we went to decimals, and it's an approximation. So there we go. Now I'm going to erase the board and work one more problem from start to finish using the quadratic formula and then calculating the approximate answer. Well, here's a quadratic equation I cooked up, and it's going to come out a little more bigger and nastier than I really intended, but I decided to go ahead and keep it for this video. So it's a little more challenging than usual, but I want to take you to the full process of solving a quadratic, simplifying it, and then calculating the approximate answer. So here's our problem. Solve 9x squared plus 12x minus 14 equals to 0. So our first step is write down the coefficients. A is equal to 9, B is equal to 12, and C is equal to negative 14. So careful about pulling off the negative signs when they're there. Now we'll plug it into the quadratic formula. X is going to be minus B, so it's going to be minus 12, plus or minus the square root of B squared, so that's 12 squared, minus 4 times A, 4 times 9 times C, negative 14. And everything is divided by 2 times A, or 2 times 9. All right, so those are the correct numbers, presumably. And now we need to simplify this. And so let's see, x would be negative 12 plus or minus, and up here we're going to have 144, and then the two negatives cancel, plus, and I think that's 504. I just want to double check myself. So 4 times 9 times 14 is 504. So when we add these numbers together, we have the plus or minus the square root of, what would that be? 648 over 18. All right, now this is the reason why I told you it's a little worse than I wanted it to be, because this, you know, kind of a big number. It's not immediately obvious that how to simplify the square root of 648. You can divide it by 4, so you can factor out a square root of 4, and that will shrink it down. It turns out that 648 is 324 times 2. 324 times 2. And the nice thing about 324 is that it's the square root, it's 18 squared. And so this ends up being 18, exactly. And so we end up with x equals to negative 12 plus or minus 18 times the square root of 2 over 18. Now, let me show you some pitfalls along the way here. One mistake students make, for example, at this point, they might try to reduce 12 over 18. Divide 6 into here and 6 into there, and get 2 over 3. And what's the problem with that is that you know, that neglects this problem. You see, this number is also divided by 18, so I can't selectively cancel just these two numbers and ignore that one. So by going through this process, at this point, now I can think about simplifying the entire fraction. And here, 6 is a common factor, so I'm going to factor 6 out, and that leaves negative 2 plus or minus 3 square roots of 2 over 18. So I factored out a common factor, and now we can divide the common factor off with the denominator. That would be okay. And so the problem is now simplified, the answer. So let me do some erasing. And I'm hearing loud noises outside. I'm wondering what that is, if that's my neighbor's loud car or if that's something else strange going on. So I paused a little bit. Sometimes you'll hear traffic going down the street because my little studio here, my bedroom, is at the front of the house, facing the street. All right, so x equals to what? Negative 2 plus or minus 3 times the square root of 2, all divided by 3. So there we go. There's our exact answer. And I'm just going to write that for reference purposes. You don't need to write that, but that is the exact answer in symbolic form. And it's been simplified as far as we can make it. Now, it'd be tempting to cancel the 3's. But again, that's that same issue. When you cancel these 3's, you're neglecting the fact that 3 is also dividing into the left-hand number. So don't do that. All right. Now let's look at the get the approximate answer. And to get that, it really pays off to rewrite these separately. So it's minus 2 plus 3 square roots of 2 over 3. And minus 2 minus 3 square roots of 2 over 3. And so by writing those separately, now we can enter them separately into the calculator and get some kind of approximate answer. So now that is a little more complicated than what I showed you earlier, because now we have 3 times the square root. So, and again, think about these as being in parentheses. So one thing you can also do is to just calculate the numerator, hit equal, and then divide by 3 and hit equal. So you can calculate a numerator separately, hit the equal button, and then divide by your denominator number. That would work fine also. Alright. So let's see what we get. And you should try this to see if you get the same answers as I do. So negative 2 plus 3 times the square root of 2 divided by 3. And I enter it just as I see it, in that order pretty much on this calculator. It's kind of nice. Alright, so the approximate answer, x would be approximately 0.748, and it has to be rounded up. And then for the other number, if you have a graphing calculator, you may have an entry key. It's possible other scientific calculators do, I'm not sure, but I have an entry key, so when I hit the entry button, it brings up this calculation again, and then I can go back and just change the plus to a minus and hit equal. And that saves me from entering everything from scratch again. And here I get negative 2.081. That one also had to be rounded up a place. So there we go. That's the approximate decimal answer. And I will typically ask for 3 decimal places. That's just me. And really in practice in real life, it just depends on what kind of precision you need to do your problem with. So there we go. This sort of took you through all the stages of solving a quadratic equation through simplifying and calculating the decimal answers.